Hello everyone, welcome to this presentation. Today we are to learn about quadratic functions. This is one of the most important topics in mathematics because it helps us understand many real life situations such as the motion of a ball, the shape of bridges, and optimization problems. In these presentations, we will discuss the definitions of a quadratic function, its general form, the graph of a quadratic function, its important characteristic, and solve an example problem together. So let's get started. Today we are going to learn about quadratic functions. Everyone, please take a look at the picture below. If we look at this picture, the Gateway Arcs and the Sydney Harbour Bridge, we can see that their shapes are similar to this one. This shape is called a parabola. A parabola is the graph of a quadratic function, just as a straight line is the graph of a linear function. In this video, we are going to learn about quadratic functions, including their graphs. Okay, general form. Let's start with the general form of a quadratic function. F of x equals ax squared plus bx plus c, where a is not equal to 0. Here, a is the coefficient of the x quadrant, b is the coefficient of the x term, and c is the constant term. Here are some examples. Okay, example 1. Phi of x equals there x squared minus 2x plus 1. Here a equals 3, b equals negative 2, and c equals 1. Okay, next. P of equals 2x squared plus the x minus 2. Here, here a equals 2, b equals 3, and c equals negative 2. And next, p of x equals x squared minus 4. Here, a equals 1, b equals 0 because there is no x term, and c equals negative 4. And next, f of x equals 5x squared minus 4x. Here, uh, at a equals 5, b equals negative 4, and c equals 0 because there is no constant term. And finally, f of x equals 7 plus 2x minus x squared. And here, even though the terms are written in a different order, we can rewrite the functions as negative x squared plus 2x plus 7. Therefore, a equals negative 1, b equals 2, and c equals 7. So everyone, you should be able to identify the values of A, B, and C, even if the terms are written in a different order. Okay, next, the graph of a quadratic function. A quadratic function has two possible graph shapes. It can either open upward or open downward like this. Okay, whether the graph opens upward or downward depends on the value of uh, a. If a is positive, the graph opens upward. On the other hand, if a is less than 0 or a is negative, the graph opens downward like this. Now let's move on to the next topic. Okay, x-intercept. The x-intercept of a quadratic function. Now, how do we find the x-intercept of a graph, including the graph of quadratic functions? If the graph of f of x intersects the x-axis, then it intersects the x-axis when uh, f of x or y equals 0. Let's look at an example. Okay, find the coordinates of the x-intercepts of the quadratic functions. F of x equals x squared minus 5x plus 6. We are going to find the x-intercepts. To find the x-intercept, we replace f of x or y with 0. Okay, so we get the solution. Um, f of x equals to x squared minus 5x plus 6. So 0 equals x squared minus 5x plus 6. Okay, we can rewrite it as x squared minus 5x plus 6 equals to 0. Okay, next we need to find the zeros of the functions, which mean we need to find the values of x. To do this, we factor the quadratic expressions. Now we need to find two numbers whose sum is -5 and whose product is 6. Those, those numbers are -2 and -3. Okay, -2 and -3. Therefore, x equals to 2, okay, and or x equals to 3. Okay, now let's learn how to find. Okay, therefore the coordinates of the x-intercepts are the point 2, 0 and the point 3, 0. Okay, uh, now let's learn how to find the y-intercepts. Y-intercepts. Okay, the y-intercept, we simply substitute 0 for x, for example. Find the coordinates of y-intercepts of the quadratic functions fx equals x squared minus 5x plus 6. We substitute 0 for x. So solution f of x equals to 2x squared minus 5x plus 6, okay? F0 equals to 0 squared minus 5 times 0 plus 6. So the coordinates of the point of intersections with the y-axis are the point 0, 6. Okay. Next, vertex or turning point or extreme point. Now let's continue. How do we determine the vertex, also known as the turning point or the extreme point? Take a look. Take a look at the graph of a quadratic function like this. The graph uh, can open downward, yeah, downward and or uh, open upward. Okay, the vertex or turning point or extreme point is located right here, like here. If the graph opens upward, then this point is the vertex. Now, suppose the vertex is represented by P with coordinates P, X, P, the point XP, uh, X, YP. How do we determine the X coordinate and the Y coordinate? Or in other words, how do we find the values of XP and YP for a quadratic functions? Okay, quadratic functions. Okay. The y coordinate of the vertex can be found using the formula xp equals to minus a negative b divided by 2 times a. And the y coordinate of the vertex can be found using the formula yp equals to negative d divided by 4 times a. And the y coordinate of the vertex can be found using the formula the b equals to b squared minus 4 times a times c. Okay. Next, this line is called the axis of symmetry. If we follow the graph along this line, but both sides will match exactly. That is why it is called the axis of symmetry. The formula for finding the axis of symmetry is the same as the formula of finding the x coordinate of the vertex. Okay, and axis of symmetry, x equals to xp equals to negative b divided by 2 times a. And now let's talk about the maximum and minimum values. The graph has a maximum value when it opens downward. The graph has a maximum value when it opens downward. The graph has a maximum value when it opens upward. The maximum or minimum value is simply the y coordinate of the vertex, so the minimum value or maximum value is negative d divided by 4 times a. Okay, thank you.